Hi guys, welcome to Maths Vision tutorial. So today we shall be talking about product rule and quotient rule. In my last video we talked about chain rule, and I believe we can use chain rule very well now, and you should be able to recognize when to use chain rule and when not to use chain rule. So now we'll be talking about product rule. So what does product rule state? Product rule states that if y is a product of two functions which you call u, v, where u and v are functions of x, that is, u is a function of x and v is another function of x. The reason why we use f of x and g of x here is because they are different. They are both what? Function of x. But if u is one function of x, it doesn't mean that the function of u is the same thing as the function of what? V. That's why we use f and g. But f and g are what? Both function of what? X. So now we now say that the differentiation of y with respect to x, you know there's no x here. So the differentiation of y with respect to x now is what? U dv dx plus v du dx. This formula is very, very important under product rule. Under product rule, there's no how you can differentiate the product of two functions without using this. So now take note of this formula as we'll be using it to solve some problems. Now, to understand what we are saying, we have example 1 that if y equals to s cubed sine x, the y ds is what? Now, if you should look at this, it is very easy for you to recognize that this is the product of what? Two functions. This is a polynomial function and this is a what? A trigonometric function. They are both multiplying themselves. So how do we solve this? We solve this using product rule. How do we start? You let the first one to be equal to what? U, and the other one to be equal to v. Now you say let u to be equal to what? S cubed, and v to be equal to what? Sine x. And the next thing now is to what? Differentiate u with respect to x using the polynomial rule. Then you have that du dx here is what? 3x squared. Because you have the coefficient of 1 here, 3 times 1 is 3, and you reduce the exponent by what? By 1. That is the rule of what? Differentiating polynomial functions. Now, the rule for differentiating trigonometric functions. I want to differentiate sine x with respect to x. And under the table for trigonometric function, it said it is what? Cos x. Right? So now, the formula for product says that dy dx is equal to what? U dv dx plus v du dx. Now, what is our u? Our u is what? X cubed. What is dv dx? dv dx is what? Cos x. Plus, what is our v? Our v is what? Sine x. And what is our du ds? Du ds is what? Du ds is 3x squared. What you just need now is to what? Is to simplify, and that's all. But don't make the mistake of multiplying x and 3x squared. Don't make that mistake. Sine x is 1 standing on its own. So 3x squared is multiplying the whole of what? Sine x. In order not to do the mistake of multiplying x by this, you can just bring this to the back, and you have that this is x cubed cos x plus 3x squared sine x. And this is our answer for the dy dx of this function. But we can just simplify further, right? Simplifying further, what is common to both terms? X squared is common. We can bring out x squared. And we have that therefore dy dx, well, bring out x squared. You have only one x remaining here. X cos x plus 3 sine x. And this is our answer for the dy dx of this function. Let's take another example. Example 2. If y is equal to what? If y equals to exponential 2x cos 3x, then dy dx is what? Is what? This is what? Product of two functions. The It's easy for you to recognize. This exponential 2x is multiplying cos 3x. This cos 3x is a trigonometric function. This one is what? Exponential function. So what do? We select one to be equal to u and the other one to be equal to what? To be equal to v, like we did here. Now we say u equals to exponential 2x and v equal to what? Cos 3x. Now we need to get what? We need to get the u dx, and here we need to get the v dx, like we did here. After letting u to be equal to the first one and letting v to be equal to the second one, the next thing is find the u dx, and the next thing is find the v dx. But you can see in the process of finding the u dx here, we didn't use chain rule, and in the process of finding the v dx here, we didn't use what? Chain rule. But here we are going to use what? We are going to use chain rule to find the u dx here, because this is exponential 2x and not exponential x. Adding b, it is exponential x. We just say that the u dx is what? Exponential x from the table, don't forget. But now this is exponential 2x. We are going to use what? We are going to use chain rule. You can just come somewhere and this is u equals to exponential 2x. Choose another variable. Let's use the w. Let w to be equal to this 2x so that u will be equal to what? Exponential w, because w is equal to 2x. Differentiate w with respect to x. The w dx, we are going to have 2 using polynomial rule for differentiation, and the u, the w, we are going to have exponential w, because we are differentiating exponential w with respect to what? W. So we are going to have exponential w under the rule for what? Exponential function. So now, chain rule says that the u dx, which we are looking for here, is equal to what? The w dx times the u dw. And this is true. It makes sense because when the w cancels out the w, we are going to have the u over the x, which is this. So the formula is true. The w dx now is what? 2, and the u dw is what? Exponential w. So therefore, the u dx is 2 exponential w, but w is 2x. You have to return it, and you have 2x. So that means our du dx is 2 exponential 2x. So we write that here. This is 2 exponential 2x. So now it remains the v dx. The v dx also requires chain rule. So now v equals to cos 3x. This is not cos x. Adding b is cos x. We just say that the v dx is what? Minus sine x. But this is cos 3x. Then we are going to use what? Chain rule. You say let's use z now. Z. Let z equals to what? 3x. If z is 3x, then v will now be what? Cos z. Cos z. Differentiate z with respect to x, that is dz dx. Using the rule for polynomial, we are going to have 3. Now, differentiate v with respect to z. Dv dz, I'm going to have minus sine z under the table for trigonometry. Now, chain rule says that what? Dv dx, which we are looking for here, is what? Dz dx times dv dz. You can see that this one makes sense too, because by the time dz cancels dz, we are going to have dv over dx, which is what we are looking for. Now, dz dx is what? Is 3. And dv dx is what? Minus sine z. So always work with brackets so that you don't make mistake. So now we are going to have that this is minus 3 sine z, right? This will give us minus 3 sine z. But what is our z? Our z is a function of x, which is 3x, so we replace it. Therefore, our dv dx is minus 3 sine 3x. Then we bring that to this place. This will be minus 3 sine 3x. Good. So we now use the formula for product rule, which says that what? dy dx equals to u dv dx plus v du dx. What is our u? Our u is exponential 2x. Dv dx, which is this, is what? Minus 3 3 sine 3x. Always work with brackets, like I told you, plus b. What is our b? Our b is cos 3x. And what is the u ds? The u ds is what? 2 exponential 2x. Then we just simplify this. We have minus 3 exponential 2x sine 3x. And the next one we are going to have 2 exponential 2x cos 3x. What is common to both sides? Only exponential 2x. We can just factor it out. And this is what we now have that. Finally our dy dx of the product of this function now is what? Exponential 2x minus 3 sine 3x, because we factor out exponential 2x, so we'll be left with minus 3 sine 3x plus, when we factor out exponential 2x also from here, we have 2 cos 3x, and that is our answer for the differentiation of this function. So now we are going to, I'm going to give you one more example, but that example will serve as a class 5 for you. Then we talk about quotient rule. Where do I claim? Okay, I can clean this place now. So, if y equals to 3x squared minus 2 raised to power 2 ln 6x, dy dx is what? Okay, let's solve this together. Let's solve it together, don't worry. So now, if y equals to this, then dy dx is what? You let one to be equal to u and the other to be equal to v. You can see this product of two functions. This is ln 6x, and this is still a polynomial with a power. So now you say, let u to be equal to 3x squared minus 2, right? So that our v will now be equal to ln 6x. Oh, sorry, u is 3x squared minus 2 raised to power 2. Because u will be this and v will be the other. So now the next thing for us is to find du over dx. But du over dx requires what? Requires chain rule. Because this polynomial is carrying another power. And this v, the v over dx also requires chain rule. Because this ln is ln 6x and not ln x. So you use chain rule to find the both, like we did for the previous one. So now, we have that, we just write u equals to 3x squared minus 2, right? All raised to power 2. Then we choose another alphabet. Let w to be this in the bracket, 3x squared minus 2, so that our u will now be equal to, since we set this to be w, our u will now be equal to u equals to w squared. Because our u will be equal to w squared, since we let this to be equal to w. Now differentiate w with respect to x using polynomial rule. The w dx will give us 2 times 3 is what? 6, right? X, reduce this by power of 1, you have 1 here. Differentiate minus 2, you have 0, good. Now, we move to the other one, du dw. This is a polynomial also. 2 times 1 will give us 2, w, reduce it by 1, you have this. Good. So now, what is the next thing for us? The next thing for us is to use our chain rule formula. Then our chain rule formula says that du dx will be dw dx times du dw. Dw dx is what? 6x, and du dw is what? 2w. Now 6 times 2 is what? 12xw, right? But that is not our final answer, because we have w here and we are supposed to get our answer in x variable. So our du dx now is 12x, our chain rule, now is 12x 3x squared minus 2. Do you get? So now we move to the next one now. The next one is what? Doing differentiating b with respect to s. Don't forget that b is what? Mean 6x. So let's choose z to be our variable now. Let z to be equal to what? 6x. So that b will be equal to mean z. Do you get? Differentiate z with respect to s. dz dx will give us 6 using polynomial rule. And now dv dz will give us what? Will give us 1 over z from the rule that if y equals to ln x, dy with respect to x is what? 1 over x. So also if b equals to ln z, dv with respect to z will give us 1 over z. So now chain rule says that what? Chain rule says that dv dx is equal to what? dv dx is equal to dz dx times dv dz. So dz dx now is what? 6, and dv dz is what? 1 over z. You know this makes sense because by the time dz cancels dz, we are going to have dv over dx, which is what is on the left. So now we have that dv over dx is now 6 over what? Is 6 over z. But don't forget that our z is a function of x, which is 6x. Then dv dx now is 6 over 6x. 6 here 1, 6 here 1, and we have 1 over x. So the differentiation of the 6x now gave us what? 1 over x. So now we can now use the formula for product rule, because this is all we need for product rule. So the formula for product rule says that dy dx is equal to what? Is equal to u dv dx plus v du dx. Our u now is our u here is 3x squared minus 2 all squared, right? And our dv dx gave us 1 over x times 1 over x plus what is our v? Our v is what? Ln 6x. du dx gave us what? du dx gave us 12x into bracket 3x squared minus 2. So now, to finally simplify this, we have that we use this to multiply the numerator, and we have 3x squared minus 2 all squared over x plus, we can just simplify this in the bracket, and we can just have this to be 12x 3x squared minus 2 ln 6x. So what can we still do to this? What we can do is just to find the what? The s here. Everything here is over 1, and we can have the SCM here to be what? To be x. X in x is what? 1. Then we have 3x squared minus 2 squared, because x here in x is 1, and 1 times the numerator will give us back the numerator. So plus 1 in x is x. So x multiplied by the numerator, we can just use the x to multiply this, and we have 12x squared into bracket 3x minus 2 ln 6x. So now, what can we still do to this? There's nothing much. We can leave our answer like this. Yes, you can stop your answer like this. And what you can also do is bring out the common factor, because 3x squared is here. 3x squared is common to the both sides. So you can just factor out 3x squared minus 2. Factor it out, but you can as well leave your answer like this. So this is the differentiation of the product of these two functions. So now we'll be talking about quotient rule, the rule for quotient rule, and let's see what that states.